coming. This might be the worst talk of the whole conference, so I'm glad to do that for you. So I can talk about why this is. I'm happy to be talking about Clojure and ClojureScript because it's the first language in a very long time that I've actually really liked to use. I did start out. I started as a professional programmer back in 1996 at IBM, and I am one of the few persons that have actually been paid to program in Smalltalk. And Smalltalk I was young and foolish back then. I didn't know how well I was off doing Smalltalk programming. And ever since then, I sort of missed what I had until I came upon Clojure. There's no screen at all. The thing about Clojure is that the thing that I missed about Smalltalk was the fact that it was a language with small syntax. I've come to realize that I really don't like languages where I have to learn syntax, arcane stuff. I just want to learn, I want the syntax to be small. Smalltalk had that, and because probably a lot of you learned Lisps at university. The thing is, there's the two of us here that do not have a university background for programming. I'm a self-taught programmer. That means that I never got across Lisp until Clojure came along. And so I started looking into it because there were enough smart people talking about it, so I started looking at it, and I came to realize that it was the same. It is not Smalltalk, but it has the same idea. Very small syntax. And the more I looked into it, the more I realized that it's not easy to understand at first, sort of a steep learning curve, but after a while, once you've learned it and you realize that while there seem to be a lot of parentheses, they're just in a different place than you're used to, so there's actually they're not more parentheses, they're just in different places. And after that, I realized that it's actually easier to understand Lisp code than other code, because syntax is very little syntax. Whereas if I'm learning Go, or I always have to learn, okay, so how do I define a variable? Oh, there's a lot of things that I have to know about the compiler. You don't have to do that for this. Include. Lisp is pretty much a functional language. I have a slide here that you can't see that says that this is not a language theory talk. I'm not equipped, or I'm not a good person to do that. This would have been a very practical talk. But Richard, who wrote, look at that. Let's see if we can do this. Right. Wow, look at that. Okay, now I'm adjusting to screen. Yeah, that's the standard for this talk. You're applauding that we have a screen. Thanks. Okay, so this is what we were going to do. 10 minutes in, and we just got started. So, this is basically the talk that I would have wanted to listen to like 5 or 6 years ago. There will be very little low-level stuff. It will basically explain the language and what you can do with it. So, hello world. Go. Terminal. No? Why are you not seeing?
Because it probably takes a lot of time to refresh.
No way. He now shares the browser.
Yeah, see, it's going up.
Oh, okay. might not be a working thing here. Okay, I'll just talk about it then. Okay, so this is how you do, I was going to show you this, but okay. So this is basically what you do. There are 2 build systems for Clojure. You need to know one to start with. Okay, it's called Liningen. You install Clojure. After you've installed Clojure, install Liningen if you're on Macs, like most people these days. I'm not. Brew install Clojure, brew install Liningen, and you're done. Then you have this thing called line that you can call. You will create projects very easily by calling line new. If you call line new app, you will an app. The first part is a template. The app is a template for something that you can just run. It will have a main method. Clojure runs on the JVM, which means that it maps to Java. The main method will be your main method in Java. You can either run it by calling line run, which will run it through the lining, or you can use the excellent command line uberjar, which will create a self-contained jar file with a main method. So once you have that, you can just do Java jar, point it to the jar, and the thing will run, which is an excellent way of packaging applications, for example, web applications. So, Clojure characteristics. This is a list, lots of parentheses. It's semi-functional, according to Rich Hickey, who's a writer. Again, to me, it's very functional. If you're coming from Java, you will find it very functional. It has state, mostly immutables. It strives to be immutable. Whenever something is mutable, you declare it explicitly as mutable, which is very good. It's a dynamic language. It's compiled, meaning that everything is turned into bytecode, even though at the same time it's when you're programming it, it feels like an interpreted language. For geek creds, this is a homoiconic language, which means that data and code looks the same. Might not seem like a very important thing, but it's awesome once you get to creating more dynamic parts of the language. And Clojure runs on the JVM, which means that we get all the benefits from the speeds of hotspot, etc. Code. Okay, cross your fingers and let's see if this works. I'm not. So far, so good. So, can you make it bigger? Oh, absolutely. Can you see that? No, we can't. I wonder if I'm going to change my. Okay, it's not moving very fast right now. I've changed this font size and the color. Let's see when the color catches up. So everything in Clojure is a list. Oh, look at that. You changed the language? That's actually not that computer.
It says it will try. Yeah.
Oh, okay. Look at that. Okay. Okay, so the first one here. Can you see where I have my cursor?
Yeah.
Yeah. Okay, so everything in Clojure is a list. This first one, this is a list. I was going to execute this, but probably not going to do that. Lists can hold anything, meaning that it's dynamically typed. List programs are actually just lists that the interpreter handles. When the interpreter, or the reader, I believe it's the actual thing, when the reader comes upon a list, it will always take the first thing in the list and assume that that is a function. So, on this line here, the first one is a plus. That means that function plus will run for all the arguments after that. That means, let's see if this works. Oh, it works. So, I'm running an Emacs now, and I have a running REPL process in the background. Everything I do right now is actually executed, evaluated, and is printed on the outside, on the side there. So that is actually running +1 and 2. And since it's just arbitrary numbers of, we can just add stuff after that. It's an arbitrary number of arguments. Actually, this is one of the most, I will probably get back to that, just realized. Okay, so, lists, if you don't want a list to be evaluated by the reader, you will explicitly tell the reader to quote it. You can either use the function quote, or you can use the reader macro, which is just a single quote over there. We have all the regular data types. We have strings. If you're coming from Ruby, you will be happy to find keywords. I was, at least. I did a lot of Python programming. I used keywords a lot. Arrays are formal lists. This is one of the things I found hard in the beginning to understand when to use arrays and when to use lists. In general, use arrays. Lists is more like an abstract data type that has all other lists implement. We have maps. They look like this. Normally, well, if you come from Python, you would call it a dict, and if you're from Ruby, it's a hash. They look like this, and there's, as you will see, there is no comma between the pair, between the tuples. If you want to introduce a comma, you can do that. Commas are treated like white space, but the idiomatic things do not use them. We can nest maps, of course. And the normal thing is to use keywords as map keys, but we can basically do anything. So this is a map where the first map key is the number 1. You can just do whatever you want to. We have sets, we have regexps. I'm not going to go into that because we're very short time. How long do I have until?
You can actually take it's an extra minute, so.
Okay, but it's until 3 o'clock, right? Okay, very well. Okay, so Clojure has something called symbols. Up here, we've just been randomly executing code. Sometimes we just want to, but sometimes we want to refer to things by name. Things referred to by name are called symbols, and this is the way we define something. It's the first part is, again, the function. We're defining something. The name we're defining is a symbol, and this is what we're binding. So right here, we're just adding a symbol, and we're binding it to the number 1. Of course, we have functions. This is a function that just basically adds, that multiplies the number by 2. If we want to use that function, this line might seem a little bit complicated, but actually what the first argument does within these parentheses is to define a function. The result of that the result in those parentheses is returned, and is now the first argument in the outer list, meaning that is a function. And we will just, and to that function we will then pass 2. That's anonymous functions, but of course we can also give functions names. We do that by assigning them to symbols. We can do it like that. We can define a doubler, name the above function, call it a doubler, and call it. But there's also a shortcut for that, and that is the def-n macro, which means that we don't have to do all the function stuff here. If you're coming from another list, you will notice that function parameters are set in arrays, as an array in square brackets rather than parentheses, and that is of course breaking with all kinds of Lisp church ideology. The idea here is that it should be more readable. It should be easier to find the argument list when reading code. I haven't done any other Lisps, so I'm used to this. I know that I've met people who have been very upset about this. Clojure has multi-arity. We have, this is a function with a greeting, and it can take 0 or 1 arguments. Either it takes a string, it takes a name, and if we have a string, we will call the function string str. Str takes a number of strings and just concatenates them and returns the result. What we have here is, if we don't pass a parameter, that means that if we pass Frederick, we will get another Frederick, and if we, oops, sorry. If we go Frederick, we will use the default value. We're going to skip. We also have multi-methods. It's a way to, if you have a completely different, if you want to have a different API for the same function, this is the area. If you want to have a different one for circle or rectangle, we can define them with a multi-method.
So multiple dispatcher and virtual methods?
Yes. Everything in Clojure is a list. We can create lists by functions, of course. And different ones. We have lists and vectors and hash sets. And nobody can give a talk about Clojure without mentioning this quote by Alan Perlis. It's better to have 100 methods acting on one data type than to have 10 data types, than to have 10 data types with 10 methods each. Take that, object orientation. And basically, everything in Lisp, in Clojure, is working on what's called a sequenceable. It's a list. It's basically you can look at it as an interface. So basically, so here's the example. The method count is the same method for a string, which will basically say how many characters it has, but it will also count the number of, it will also count the number of members in an array. This is the reason why I turned off the phone. Oh. But it will also count members in a map. If you're coming again from Lisp, car and CDR has now readable names. They're called first and rest. Again, some people are very upset about this. We can access dict by the method get. So here we have a dict, and we're asking for whatever has the index, the keyword :A, we'll get that back. We can also, if we're using the method get, we can also provide a default method, a default value. Now, one crazy thing is that what you normally do is that the key can also be a method. So instead of using get, you would just put the key first. That would be called as a method on the map as a getter function. And you can modify arrays, etc. You can ask for max by max. Well, I'm not going to go into this. We will, if you want to change, you can change arrays in different ways. You use these functions into associate in, etc. To use that. We have loops and blocks. Catching up now, like that. Let is a function. We can have locally scoped variables using the let assignment. So here we're basically saying let number of cars assign to number of cars the value of this function and write it out. We have an if statement. If it's true, the first statement is basically if predicate, first statement, second statement. If it's true, the first statement will be executed. If it's false, the second statement will be executed. For those of you wondering, if is not a function, it's what's called a special function that they read because it's implemented, especially implemented in the language, because it will only execute one of the two. If you only have one of them, you can use when, which just takes one of them. It just takes one statement. We have standard use of or and. And thank you. We can ask if something is nil. There's a function. There's a function for that. And nil is falsy, which is also good to know. We have a for loop, which will again take its parameters in square brackets. We have a loop. Clojure implements tailcode recursion by using this keyword. If you copy it, it doesn't have implicit. It doesn't do it implicitly. But if you want to do recursion, want to have tailcode recursion optimized, you will have to use the recur keyword, which will magically tell the underlying stuff to do the right thing. Clojure has a lot of things about immutability. You will read about transactional memory. When you start out with Clojure, I've been doing Clojure for I have to say, this is my sort of enthusiast talk. I have yet to be paid to do Clojure, and so far I've only had to use atoms. There are other things where if you're modifying more than one thing at the same time, there is transactional memory that you can sort of set up a transaction, have it roll back if you want to do thread-safe multiple modifications. So far, I've been getting by using atoms. Atoms are thread-safe, and they're initialized by the function atom, and we supply an initial value, in this case an empty map. And we modify by using either the function swap or the function reset, which will, if you're coming from Ruby, you will notice that things that modify stuff or has a side effect is normally marked, is idiomatically marked with an exclamation mark, saying that this will actually modify stuff. If you have an atom and you want to access the value, you will need to deref it. If you just want to look at the atom, it is actually, you can't just look at the atom itself. It is more than its value. It looks like that. It is implemented as an object. But if you either call the function deref or use the Ruby-esque version of putting an @ in front of it, you will do that. You will get the same version. You will get the same result. Let's skip destructuring and go straight for higher order functions. First of all, one thing to learn is that everything is just functions. This is one place, this is one way of declaring. It's all functions and data, we can actually have a list of symbols and say, okay, whatever is first, give that to me, and then multiply it. So this is where the idea of code as data and data as code becomes very powerful. If you're coming from other functional languages, if you've done Python or Ruby, you will, or even Java these days, right? With the lambdas, you will have maps, filters. You can do reduce. Once I got used to doing functional style programming, I found it very hard to let go. I tried to take up Go programming. Then I got to my first case where I had a collection and I wanted a new collection from that, and I had to start to iterate and create a temporary variable. I got halfway through that loop and said, screw this. I'm always happy when somebody else is using Go. I like code that is written in Go when it's compiled and done. Okay. Basically takes the first three from a list, drop, does the same thing but drops them. One interesting thing is that Clojure works with lazy evaluation, which means that we can work with infinite sequences. Repeat here actually returns an infinite sequence of the string 1 million bottles of beer on the wall. But it's not realized yet. It's just promised. It will eventually give you that if you ask for it. So I'm not going to take 100. I'm just going to take 10 of that, and it will still. This time it will only just realize 10 of them. This is a function. Repeatedly takes a function and calls it again an infinite amount of time in theory. This is a shortcut for an anonymous function which will return a random integer between 1 and 10 and 0, probably 0 and 9. Yeah, no details. But it will just take 3 of them. But again, might as well just say, might as well use 30. Doesn't really matter. So it's easy to set up and do things like that. Skip closures, partials and complement. Clojure has very nice async. If you look at Go and Go channels, Clojure has that as well. I'm not gonna. Again, it's like transactional memory. Something that is there. I've not yet used it. What I have used is futures. Futures is a very easy way of basically saying, I want to run something. Whatever. Whoa. Damn. Whatever. Okay. It all got very intimate now. Whatever comes after, whatever the future returns, is here assigned to the value to a, and we're then gonna deref it. So this is a very easy way. Whatever is in the future will start on a separate thread, and whenever the thread is done, we will return it. Yes.
So the main thread will not be blocked?
No, it's not. Which is a very easy way. For example, if you're writing a web application and you want to do something, make a call to a database and then do something else in between, just do the database call in the future, then deref it when you want it. As soon as you deref the future, your main thread will block, because now you're saying, okay, I need that, the thing that I asked. But as long as you're not asking for the value for the result from the future, you're fine. You can also work with promises, etc. But futures is just a very simple way of doing. And a little heads up: the excellent part about futures is that they're also available in ClojureScript.
which I will talk a little bit about later, which means that you will not have to do the crazy callback in Java. Instead of doing crazy callbacks in JavaScript, you will have readable futures in ClojureScript. A lot better. If you want to, you can have Java interrupt. Java interrupt, this is something that basically builds a very ugly swing application. But basically, Java objects is just available like this. Normally, you will find. Normally, you would go out and find a Clojure wrapper library somewhere, because after a while, this just gets ugly. But everything is available right out of the box. Ah, crap. Macros. Can't do a Lisp talk without mentioning macros. Oops. Okay. So macros is the one thing that I've missed in other languages, and it's code that writes code. This is an example that I've had in that is a practical example where I've used it. Normally, when you write, one way to write HTML in Clojure is to use a language called Hiccup, which is basically data structures which will be returned as HTML, which will be converted into strings at the end. And what we're looking for here is code that looks a little bit like this. What I want to do is I want to have something called body, and then I want a form, and then I want a text field, I want a password field, and a date field. That's readable, I understand what's happening. If I wanted to define that as functions, that means that I would have to define first a function called text field, then a function called password field, and then a function called date field. If I want to have that kind of syntax, I could, of course, somebody might argue, say that I could have the type, again, passed as a parameter, but that would sort of defeat the purpose. I want it to be readable. And defining functions like this, and of course, after a while, we want to have other fields as well, and they will be very similar, but still crucially different. Which is kind of tedious and error-prone. So instead, we can use a macro. A macro is code that writes code. So this is a macro called define a field. It will take a field type, and it will write the function definition for me. After I've done this, I now have a macro called def field, and I can call it by saying, so I want a field for dates, I want a field for passwords and text, and after that I'm done. So I'm only writing code once. Macros are very nice, also very error-prone. They're sort of scary because it turns your code a little bit less readable, but I definitely, as long as it's small and easy, I do prefer them. Now, I have 4 minutes, and I wanted to get back to ClojureScript. ClojureScript is it's actually quite fast now. ClojureScript compiles to JavaScript. It's sort of Clojure's cousin. It's almost the same language. It doesn't really have macros. You can do macros in a sort of ugly way using Clojure. It's not really there. It doesn't have transactional memories, but it has atoms. And of course, it's a little bit different when you call out to native JavaScript instead of to native Java. So we're actually going to do a very quick demo. Hopefully it will work. Let's hope I didn't do that. Ah, crap. Oh well. I did this before. Let's just do it anyway. So I created. I've now created a whole web app using. There are two basic large frameworks for creating HTML dynamically in JavaScript. It's either Regent or Ohm. They're both based on React.js. Ohm is very powerful, and it seems brilliant. I just have a very hard time understanding it. It's probably my fault. And Regent, on the other hand, maps more closely to how my brain works, and I find it very easy to understand. Let's see if we can. Okay, so this will be very hard in. Okay, no. Sorry, my screen is completely different now. Okay, eventually we'll probably get there. No. Okay, this is where okay, I'll just tell you what you should have seen. You really should try. If you're doing any sort of web development, do try out ClojureScript, because it's, first of all, you don't have to do JavaScript. Total win. Because you lose all the, like a good friend of mine said, it's bringing the good Lisp to the browser instead of taking the bad Lisp to the server. Hint node. And it's, no, I don't think we're going to see this, right? The thing is, there's a lot of funny things, cool things happening in the ClojureScript community. And you get stuff like live... no, we're done. Seems like we're dead. Yeah. Oh, okay. This... Let me just finish ClojureScript, and I'm done. So do try out ClojureScript. Do look for Regent. I was going to show you live code reloading. The cool thing is that you can actually do programming, and once you save it, you will have the browser will automatically reload, and it also works with CSS, which means that the turnaround time for creating GUIs is really good. Also, this means that I cannot show you the last slide that I promised to show, and that is now coffee break, and Kentor is sponsoring it. I promised to have that slide. I can't do it. I'm sorry about that. But it's Kentor, good people. They're buying you coffee. Okay, that's it. Thanks for staying and not walking out of me. I'm very sorry that I probably got to show you 50% of what I had, but thanks for not throwing tomatoes at me. And is there anybody who has any questions? If not, I will be around for a little while longer. If you just.
What do I need to get started with ClojureScript?
You will need, first of all, okay. First of all, a good thing, not much really. Go to Regent. There are a number of sites to try. If you look at my Twitter stream, I'm MHNVE, Manvi. I posted a link just a few days ago to where you can try out ClojureScript in your browser. You don't it's Regent, and you just write code in the browser, and you can just try it out without anything. You don't have to install anything. After that, go to the ClojureScript site or the Regent site. You don't need Clojure to do ClojureScript. You can build something in ClojureScript, pack it up as just regular JS, and have it served by a static HTML file. So you don't need Clojure at all. But once you get started with either Clojure or ClojureScript, I suggest getting a good editor, because the whole thing is actually getting into the usage of the REPL. And I'm using Emacs. If you have the time and the determination, you should do it. Emacs is awesome. But if you're, for example, coming from IntelliJ, There is cursive, that is very popular. And there's also, if you just want to start something very easy without buying anything, there's light table or night code, which is also Clojure editors that works right out of the gate. Yeah, but I would encourage you to most probably install Clojure and lining in because it helps, because that gives you access to all the templating. It's a whole lot easier to get started by just writing a line in new and then look at whatever templates you have. Okay, thanks a lot for coming.